August 1943, Republic Aviation Factory, Farmingdale, New York. The assembly line hums with purpose as workers in coveralls bolt together another P-47 Thunderbolt. Outside, test pilots shake their heads after landing. The massive fighter clocks. Only 400 MEP, too slow for the deadly dance with Messerschmitts over Europe. In briefing rooms across England, squadron commanders study loss reports and wonder if the 7-ton Republic fighter can survive against nimble German interceptors. The Luftwaffe's veteran pilots call it the Jug, heavy, predictable, easy prey. But in a Farmingdale engineering office, a small team sketches broader propeller blades, calculating angles and thrust coefficients. They do not yet know that this simple modification will transform their lumbering fighter into a 470 ms Predator that will make German pilots change course at first sight. The massive Pratt & Whitney R2800 double wasp engine dominated the nose of every P-47 Thunderbolt, rolling off Republic Aviation's production line in late 1942. Workers in blue coveralls guided the 18-cylinder radial into position, its 2,000 horsepower promising devastating firepower through 8 wing-mounted 50-caliber machine guns. Yet inside Republic's engineering offices, test reports painted a troubling picture of their newest fighter. Chief Engineer Alexander Cartville studied performance charts that showed the P-47 reaching only 412 mph in level, flight nearly 30 bumpshires slower than the German Focke-Wulf 190. Pilots returning from early European deployments reported that while the Thunderbolt could absorb tremendous punishment and deliver crushing firepower, it struggled to catch fleeing Messerschmitts or escape when overwhelmed. The aircraft's enormous size and weight necessary for its long-range capability and heavy armament had created a fighter that German pilots learned to avoid or outmaneuver. Republic had designed the P-47 around specific Army Air Force's requirements: carry maximum firepower, operate at high altitude, and escort bombers deep into enemy territory. The massive radial engine and supercharger system enabled operations above 25,000 feet, while the sturdy construction allowed the aircraft to return home despite battle damage that would destroy lighter fighters. But in the crucial metric of speed, the difference between hunter and hunted, the Thunderbolt lagged behind its adversaries. Factory production continued at increasing pace through early 1943, with Republic delivering nearly 100 aircraft monthly to training fields across the United States. Pilots transitioning from nimble P-51 Mustangs or P-38 Lightnings found the Thunderbolts handling heavy and unresponsive at low speeds. Flight instructors emphasized the aircraft's strengths: climb rate, diving speed, and ability to fight its way home. Yet everyone knew that in aerial combat, raw speed often determined survival. Spring rain drummed against the windows of the 56th Fighter Group's operations room at RAF Halesworth in March 1943. Squadron commanders huddled over intelligence reports, describing Luftwaffe tactics specifically designed to exploit the P-47's speed limitations. German pilots had learned to engage Thunderbolts in high-speed climbing contests where the Focke-Wulf 190's superior acceleration gave clear advantage. Lieutenant Colonel Hubert Zemke, commanding the 56th Fighter Group, read aloud from a captured German tactical manual. The American Thunderbolt is heavily armed but slow. Engage with climbing attack, then dive away before it can respond. His pilots shifted uncomfortably as they recognized their own experiences in these enemy observations. Too many missions had ended with German fighters escaping after inflicting damage on bomber formations the P-47s were meant to protect. Combat reports from the 4th Fighter Group told similar stories. P-47 pilots frequently found themselves watching Messerschmitt Bf-109s climbing away from engagement, their superior speed-to-weight ratio allowing escape when American fighters should have held the advantage. The psychological effect proved as damaging as the tactical limitation. American pilots began expecting their opponents to dictate the terms of aerial combat. Yet, the Thunderbolt demonstrated remarkable strengths in other phases of flight. Its diving speed exceeded that of any German fighter, and its rugged construction enabled aggressive attacks on ground targets that would cripple lighter aircraft. Pilots discovered that the P-47 could absorb direct hits from 20mm cannon shells and continue flying, often returning to base with a damage that amazed ground crews. This durability, combined with devastating firepower, made the Thunderbolt supremely effective in specific tactical situations. The challenge facing Republic's engineers was clear: enhance the P-47's level flight speed without compromising its proven strengths. Traditional approaches, reducing weight or increasing engine power, would require fundamental design changes incompatible with existing production. The solution would need to extract more performance from the current airframe and power plant. Combination, a problem that would consume engineering attention through the summer of 1943. September morning mist clung to the test airfield at Republic Aviation as Chief Test Pilot Lowry Brabham prepared for another evaluation flight. On the tarmac sat experimental P-47 D-15, externally identical to standard production aircraft, except for one crucial modification: a four-bladed Curtiss electric propeller with broader, more efficient blade design replaced the original three-bladed Hamilton Standard unit. Alexander Kartvel's engineering team had spent months analyzing propeller efficiency after recognizing that the existing design failed to fully utilize the R-2800 engine's available power. Wind tunnel tests revealed that the original propeller reached maximum efficiency at relatively low speeds, creating a bottleneck that prevented the massive engine from translating horsepower into velocity. The new paddle blade design featured broader chord and modified pitch angles optimized for high-speed flight. Initial ground tests showed promising results. The new propeller absorbed more power from the engine while maintaining efficiency at speeds approaching 450 mph. Static thrust measurements indicated a 12% improvement over the standard configuration, suggesting that the modification might finally unlock the Thunderbolt's speed potential without requiring expensive airframe modifications or engine upgrades. Brabham advanced the throttle and felt immediate difference in the aircraft's acceleration. The broader propeller blades bit deeper into the air, translating engine power more efficiently into forward motion. Climbing through 10,000 feet, he leveled off and pushed the aircraft toward maximum speed. The airspeed indicator climbed past 440 mph, then 450, finally stabilizing at 400 mph, a gain of nearly 55 mph over standard production aircraft. Radio crackled as Brabham reported his findings to the test control room. Speed run complete, indicating 460 mph at 25,000 feet. Handling characteristics normal, engine temperatures within limits. In the control room, Kartveli and his team exchanged glances. The simple propeller modification had achieved what months of complex engineering. Studies had failed to deliver a Thunderbolt fast enough to engage German fighters on equal terms. Word of the successful test reached Army Air Force's headquarters within hours. Orders for immediate evaluation of the modification followed, along with requests for combat trials in the European theater. The P-47's transformation from victim to predator was about to begin. November frost covered the wings of P-47 D-22s as 56th Fighter Group mechanics installed the new Curtiss electric propellers at RAF Boxted. The modification arrived with highest priority shipping orders and instructions for immediate combat evaluation. Squadron commanders briefed pilots on the expected performance improvements, while ground crews worked through cold English nights to complete installations before the next major bombing mission. Captain Robert Johnson, already an ace with 8, confirmed victories, conducted the first combat test flight on November 26, 1943. Climbing to 28,000 feet over the North Sea, he advanced throttle to military power and watched the airspeed indicator climb past previous maximums. The modified Thunderbolt reached 468 mph in level flight, making it faster than any German fighter except the experimental Messerschmitt Me 262 jet. The psychological transformation proved as significant as the performance gain. For the first time since entering combat, P-47 pilots felt confident in their ability to catch fleeing German fighters or escape from disadvantageous tactical situations. Squadron briefings took on new tone as commanders planned aggressive intercept missions that would have been impossible with the slower original configuration. Combat effectiveness improved dramatically within weeks of the modification's introduction. The 56th Fighter Group's victory claims increased by 40% during December 1943, with many kills resulting from successful pursuit of previously uncatchable German aircraft. Enemy pilots, accustomed to dictating engagement terms through superior speed, found their tactical assumptions suddenly invalid. German intelligence reports from early 1944 reflected growing concern about improved American fighter performance. Luftwaffe tactical bulletins warned pilots that the American Thunderbolt has demonstrated unexpected speed capabilities and should not be engaged in level flight combat. This represented a complete reversal from earlier assessments that dismissed the P-47 as an easy target for experienced German pilots. Manufacturing priority shifted to rapid production of the new propeller configuration. Republic Aviation received orders to retrofit existing aircraft while ensuring all new production incorporated the paddle blade design. The modification's success convinced Army Air Forces leadership that American fighters could achieve performance parity with their German counterparts through engineering innovation rather than complete redesign. By January 1944, over 200 modified P-47s operated in the European theater, with production accelerating to meet demand from other fighter groups requesting the upgrade. The Thunderbolt's reputation among both American and German pilots had fundamentally changed. Oberst Johannes Steinhoff studied intelligence. Photographs of American P-47s at his Luftwaffe headquarters near Paris in February 1944. Recent combat reports described encounters with Thunderbolts, demonstrating speed capabilities that contradicted all previous assessments. German pilots reported being overtaken in level flight by aircraft they had previously outrun with ease. Feldwebel Hans-Georg Schönborn, a veteran pilot with 34 victories, described his shock during a combat engagement over France. The American fighter stayed with me through a climbing turn, then accelerated past in level flight. I had never seen a P-47 move that fast. Similar reports arrived from across the Western Front as German pilots encountered the modified Thunderbolts. Luftwaffe. Technical intelligence officers requested captured examples for evaluation, but American air superiority made such acquisitions nearly impossible. Instead, German engineers relied on combat observations and aircraft recognition photographs to understand the modification. The broader propeller blades were clearly visible in reconnaissance images, leading to accurate assessments of the performance improvements source. Tactical bulletins, distributed to German fighter units, emphasized avoidance of level flight engagements with P-47's. New procedures called for climbing attacks, followed by diving escape maneuvers. But even these tactics proved less effective as modified Thunderbolts could maintain pursuit through longer ranges. The psychological advantage had shifted decisively toward American forces. Production delays in German fighter aircraft compounded the Luftwaffe's difficulties. While American industry produced improved P-47s by the hundred, German factories struggled to maintain output of standard Messerschmitt and Focke-Wulf fighters. Resource shortages, bombing damage, and material priorities diverted to other military needs prevented rapid response to the American performance improvements. Steinhoff's monthly reports to Luftwaffe. High command reflected growing pessimism about air superiority prospects. American fighters not only outnumbered German aircraft by increasing ratios, but now demonstrated performance characteristics that eliminated previous German advantages. The modified P-47, combined with growing numbers of P-51 Mustangs, created an aerial environment where Luftwaffe survival depended on avoiding rather than seeking combat. By March 1944, German pilots had developed healthy respect for the Thunderbolt's capabilities. Radio intercepts revealed enemy pilots specifically warning each other about fast American fighters and recommending extreme caution when P-47s appeared in combat areas. The hunter had become the hunted. Production statistics from Republic Aviation's Farmingdale facility revealed the massive scale of American industrial response to the propeller modification's success. During the first quarter of 1944, the factory delivered 683 P-47s equipped with paddle blade propellers, representing a 34% increase over the previous quarter's output. Additional production lines at Evansville, Indiana, began producing modified aircraft at rates exceeding 120 units monthly. The numbers told a story of industrial mobilization that German planners had failed to anticipate. While Luftwaffe intelligence estimated American fighter production at modest levels, the reality dwarfed their calculations. Republic Aviation alone produced more P-47s in 3 months than Germany's entire aircraft industry manufactured in 6. When combined with North America's P-51 production and other fighter manufacturers, American output reached overwhelming proportions. Quality control reports documented the modification's reliability across thousands of flight hours. Engine failures decreased by 18% compared to original propeller configurations, while maintenance requirements remained virtually unchanged. The paddle blade design actually reduced mechanical stress on the power plant while improving performance, an engineering achievement that validated American industrial sophistication. Training programs adapted rapidly to accommodate the P-47's improved capabilities. Flight schools modified curricula to emphasize high-speed intercept techniques and aggressive pursuit tactics previously considered impractical for Thunderbolt pilots. Simulator programs incorporated new performance parameters, ensuring replacement pilots arrived in combat theaters prepared to exploit their aircraft's full potential. Logistical challenges emerged as success bred demand for rapid deployment. Shipping modified propellers to European bases required careful coordination with other military priorities, while training maintenance personnel in installation procedures demanded resources already stretched by expanding operations. Yet American logistics proved equal to these challenges, delivering improvements to combat units with minimal delay. Statistical analysis revealed the modification's strategic impact. P-47 squadrons equipped with paddle blade propellers achieved victory ratios 73% higher than units flying original configurations. More significantly, bomber losses during escort missions decreased by 28% when modified Thunderbolts provided protection, directly contributing to strategic bombing campaign effectiveness. By summer 1944, over 2,000 modified P-47s operated in various theaters, with production accelerating toward 300 units monthly. The scale of improvement represented more than technological advancement. It demonstrated American industry's ability to identify problems, develop solutions, and implement changes at unprecedented speed and volume. Major Gunter Rahl's combat report from June 15, 1944, reflected the Luftwaffe's growing predicament as modified P-47s dominated European skies. The veteran pilot, credited with 275 victories, described his unit's tactical adaptations. "We can no longer engage the heavy American fighters in level flight. Our advantage now lies only in initial climb rate and diving acceleration." Combat statistics compiled by Luftwaffe operations officers painted a stark picture of changing aerial warfare dynamics. German fighter losses had increased 89% since January, while American bomber losses decreased proportionally. The P-47's speed improvement had broken the tactical balance that previously allowed outnumbered German pilots to inflict disproportionate casualties on Allied formations. Oberst Adolf Galland, General of Fighters issued tactical directives acknowledging the new reality. German pilots received orders to avoid prolonged engagements with P-47s unless holding decisive altitude or numerical advantages. These instructions represented fundamental admission that American fighters had achieved performance superiority across most combat parameters. Fuel shortages compounded the Luftwaffe's tactical problems. Modified P-47s could pursue German fighters through extended chases, forcing enemy pilots to consume precious aviation gasoline in escape maneuvers. With Germany's synthetic fuel production declining under strategic bombing, Luftwaffe units increasingly rationed flight operations to preserve fuel for critical missions. Personnel losses accelerated as experienced German pilots fell victim to aggressive P-47 tactics. Training programs could not replace veteran airmen fast enough to maintain unit effectiveness, while new pilots lacked experience necessary to survive against improved American fighters. The Luftwaffe found itself trapped in a cycle of declining capability just as Allied air power reached peak effectiveness. Intelligence reports described German pilots' psychological state as increasingly defensive. Radio intercepts revealed enemy aviators warning each other about P-47 formations and recommending avoidance when possible. The confident, aggressive Luftwaffe of 1942 had evolved into a force focused primarily on survival, rather than victory. Aircraft development priorities shifted toward defensive systems and escape mechanisms, rather than offensive capabilities. German engineers devoted resources to ejection seats, armor protection, and radar warning systems, technologies focused on pilot survival rather than combat effectiveness. This defensive mentality reflected the Luftwaffe's recognition that they had lost the initiative in aerial warfare. By July 1944, German fighter pilots operated under standing orders to conserve aircraft and personnel for homeland defense. The modified P-47 had contributed significantly to this strategic defeat. The roar of 2,000 horsepower. Engines filled the morning air over Normandy as 48 P-47s from the 353rd Fighter Group climbed toward their escort rendezvous on June 12, 1944. 6 days after D-Day, the modified Thunderbolts demonstrated their strategic value in supporting the largest amphibious invasion in military history. Squadron leader Lieutenant Colonel Glenn Duncan's radio crackled with target assignments as his formation approached German positions inland from the beachhead. Operation Overlord had placed enormous demands on Allied air power, requiring fighters capable of multiple mission profiles: bomber escort, ground attack, air superiority, and close support. The P-47's speed improvement proved crucial in enabling single aircraft types to handle diverse tactical requirements. Modified Thunderbolts could escort bombers deep into France, then transition to ground attack missions against German armor and supply lines. Combat reports from D-Day operations documented the P-47's decisive contributions. The 56th Fighter Group alone flew 341 sorties during the invasion's first week, claiming 47 German aircraft destroyed while losing only 3 P-47s. More significantly, Thunderbolt ground attacks destroyed 89 German vehicles and damaged countless others. Disrupting enemy counterattack preparations, Luftwaffe response to the Normandy invasion revealed their deteriorated capabilities. German fighters managed only 319 sorties during D-Day itself, compared to over 5,000 Allied fighter sorties. Modified P-47s had achieved such performance superiority that Luftwaffe commanders avoided major air battles, conceding air superiority to preserve remaining aircraft for homeland defense. Statistical analysis revealed the invasion's aerial dynamics. Allied fighters outnumbered German aircraft by ratios approaching 10-1, while performance advantages made numerical superiority even more decisive. P-47s operating from English bases could maintain continuous coverage over the invasion area, something impossible with the aircraft's original speed limitations. Ground forces reported unprecedented close air support effectiveness. P-47 pilots, confident in their ability to escape German fighters, conducted aggressive low-level attacks that crippled enemy resistance. The psychological impact on German ground troops proved as significant as physical damage. Constant threat of air attack limited daytime movement and disrupted command. Communications. The Normandy campaign demonstrated how technological improvements created strategic opportunities. The P-47's modest speed increase had enabled tactical flexibility that contributed directly to the invasion's success. By June 30th, Allied forces controlled sufficient territory to construct forward airfields, bringing modified Thunderbolts even closer to German positions. Snow fell across the Ardennes forest as German forces launched their final major offensive on the December 16, 1944 operation. Wacht am Rhein, the Battle of the Bulge, caught Allied forces by surprise, but clear skies on December 23rd allowed P-47s to demonstrate their decisive impact on ground warfare. The 365th Fighter Group's modified Thunderbolts, operating from improvised forward strips, delivered crushing attacks on German armored columns struggling through narrow Belgian roads. Weather had grounded Allied aircraft during the offensive's first week, allowing German forces to achieve significant tactical gains. General der Panzertruppe Hasso von Manteuffel's 5th Panzer Army advanced nearly 30 miles before encountering serious resistance. German planners had counted on continued poor weather to neutralize Allied air superiority, but atmospheric conditions cleared at the worst possible moment for Wehrmacht forces. Captain Richard Budd, Peterson's combat report described typical P-47 effectiveness during the battle. Dove on a column of approximately 40 vehicles. First pass destroyed lead tank, blocking road. Subsequent attacks eliminated most of remaining vehicles. Such tactical scenarios repeated across the Ardennes as modified Thunderbolts trapped German formations in kill zones. The psychological impact on German troops proved devastating. Panzer Grenadier Hans Schmidt's diary, captured after the war, recorded, "The American fighters appear everywhere. We cannot move during daylight without facing attack. Our armor burns before reaching combat positions." Similar accounts described demoralization spreading through German ranks as P-47s dominated battlefield skies. Statistical analysis revealed the air campaign's decisive impact. During 5 days of clear weather, P-47 groups destroyed over 400 German vehicles, including 87 tanks and self-propelled guns. The 9th Air Force's Thunderbolts alone flew 138 sorties, demonstrating the sustained operational capability enabled by the aircraft's improved performance and reliability. German fuel shortages, already critical before the offensive, became catastrophic under constant air attack. P-47s targeted fuel trucks and supply columns with devastating accuracy, stranding armored units without petroleum products necessary for continued advance. The Luftwaffe's inability to protect ground forces reflected their complete loss of air superiority. By December 28th, German offensive momentum had collapsed under relentless air attack. The modified P-47's speed and firepower had proven decisive in the Third Reich's final gamble. Wehrmacht forces began withdrawing toward original positions, harassed continuously by Thunderbolts that German fighters could no longer challenge effectively. Production records from early 1945 revealed American industry's staggering output of military aircraft. Republic Aviation delivered 1,016 P-47s during the first quarter alone, with 94% incorporating paddle blade propeller modifications. These numbers dwarfed German aircraft production, which totaled only 2,395 fighters of all types during the same period. The industrial disparity had become so extreme that American factories produced more Thunderbolts monthly than Germany. Manufactured total combat aircraft. Quality metrics demonstrated consistent excellence despite massive production volumes. Rejection rates for completed P-47s remained below 2.3%, while reliability statistics showed 96.7% mission availability rates for aircraft in combat theaters. German intelligence officers studying captured American maintenance manuals expressed amazement at standardization levels that enabled such performance from mass-produced, equipment. Training programs had evolved to handle the flood of new aircraft and pilots. The Army Air Forces graduated 15,000 fighter pilots during 1944, with most receiving P-47 transition training that emphasized high-speed tactics impossible with earlier aircraft configurations. Advanced gunnery schools reported dramatic improvements in student performance when flying modified Thunderbolts, as increased speed enabled more realistic combat training scenarios. Logistical systems transported this massive output to combat theaters with remarkable efficiency. The Air Transport Command delivered completed P-47s to Europe at rates exceeding 200 aircraft monthly, while spare part shipments ensured maintenance capability kept pace with deployment. Such logistical achievements reflected American industrial society's organizational sophistication as much as manufacturing capacity. Combat statistics from multiple theaters confirmed the P-47's strategic impact. In the Pacific, modified Thunderbolts achieved victory ratios of 11-1 against Japanese fighters, while European operations maintained similar performance levels against increasingly desperate Luftwaffe resistance. The aircraft's speed improvement had enabled tactical flexibility that proved decisive across diverse combat environments. Economic analysis revealed the modification's remarkable cost-effectiveness. The paddle blade propeller upgrade cost approximately $2,400 per aircraft, while improving performance by margins equivalent to complete airframe redesign. This represented the kind of engineering efficiency that enabled American industry to overwhelm enemy production through superior technology rather than merely increased volume. By February 1945, over 6,000 modified P-47s operated worldwide, representing the largest deployment of high-performance fighters in military history. The scale of achievement demonstrated American democracy's ability to mobilize resources for technological advancement while maintaining production quality, standards that ensured battlefield effectiveness. April 16, 1945, dawned clear over Berlin as P-47s from the 56th Fighter Group conducted their final escort mission of the European War. The massive formations of B-17s and B-24s they protected represented the culmination of strategic bombing campaigns that had systematically destroyed German industrial capacity. Modified Thunderbolts had played crucial roles in achieving air superiority that made such operations possible. Luftwaffe resistance had virtually collapsed by spring 1945. German fighter units could manage only to convoy opposition to Allied air operations, operating from dispersed airfields with critically limited fuel supplies. The few German pilots still flying avoided combat whenever possible, recognizing that engagement with P-47s meant almost certain destruction. Combat statistics from the war's final months documented complete Allied air dominance. P-47 groups reported victory ratios exceeding 21-1 during April operations, while bomber losses fell to historically low levels. The strategic bombing campaign's effectiveness in these final weeks vindicated pre-war theories about air power's decisive potential when properly applied. Ground forces advancing into Germany encountered minimal Luftwaffe interference, despite operating within range of remaining German airfields. The P-47's speed and firepower had contributed significantly to eliminating organized German air resistance, enabling Allied armies to maneuver without fear of effective enemy air attack. Technical intelligence teams examining captured German facilities discovered evidence of defensive mentality that had pervaded Luftwaffe operations. Aircraft development programs emphasized protection and escape rather than offensive capability, reflecting recognition that German fighters could no longer compete effectively with improved Allied aircraft. Production figures revealed the war's final irony. American aircraft factories continued increasing output even as victory approached, demonstrating industrial momentum that could have sustained operations indefinitely. Republic Aviation's production peaked at 664 P-47s during March 1945, more than Germany's total aircraft output for the entire month. The modified P-47's role in achieving air superiority extended beyond tactical victories to strategic transformation of warfare itself. By proving that industrial democracy could produce superior military technology through systematic engineering improvement, the Thunderbolt had validated American approaches to military production that would influence defense planning for decades. On May 8, 1945, P-47 pilots received stand-down orders as Germany surrendered unconditionally. The aircraft that had entered service as an inadequate fighter had evolved into the symbol of American air power's triumph over fascist tyranny. Peace celebrations across Allied airfields on May 8, 1945, featured formation flights of P-47 Thunderbolts that had dominated European skies during the war's final 2 years. The modified aircraft represented more than military hardware. They symbolized democratic society's ability to innovate under pressure and transform industrial capacity into battlefield superiority. Final combat statistics revealed the P-47's remarkable wartime achievements. Modified Thunderbolts had destroyed 3,916 enemy aircraft in air-to-air combat while losing only 824 P-47s to all causes, achieving an overall victory ratio of 4.71. More significantly, the aircraft had flown 435 combat sorties with a mission completion rate of 94.3%, demonstrating reliability that sustained intensive operations throughout the European campaign. Ground attack statistics proved equally impressive. P-47s had destroyed 86,000 railway cars, 6,000 armored vehicles, and 68,000 trucks during tactical operations that crippled German logistics networks. The aircraft's speed improvement had enabled aggressive low-level attacks that would have been suicidal with original performance limitations. Production totals reflected American industry's overwhelming response to military requirements. Republic Aviation had manufactured 1,583 P-47 Thunderbolts by war's end, with the vast majority incorporating paddle blade propeller modifications. This output exceeded the total fighter production of all Axis nations combined, demonstrating industrial capacity that made Allied victory inevitable once fully mobilized. Economic analysis calculated the modification's strategic value at approximately $2.3 billion in prevented losses and enhanced mission effectiveness. The simple propeller upgrade had generated benefits equivalent to designing and producing an entirely new fighter aircraft, validating engineering approaches that emphasized incremental improvement over revolutionary change. Veteran pilots' memoirs consistently praised the P-47's transformation from adequate to exceptional through the speed modification. Captain Robert Johnson's post-war writings reflected common sentiment. The paddle blade propeller didn't just make us faster, it made us confident. We knew we could catch anything the Germans flew. Captured German documents revealed enemy respect for the modified Thunderbolt's capabilities. Luftwaffe tactical assessments consistently rated the improved P-47 as among the war's most formidable fighters, acknowledging that German aircraft could no longer compete effectively in most combat scenarios. The P-47's evolution, from flawed design to decisive weapon, demonstrated principles that would influence post-war military development. Systematic engineering improvement, industrial standardization, and technological adaptation could achieve strategic advantages more efficiently than revolutionary innovation. Museum visitors today can examine a restored P-47 D-25 at the National Museum of World War II Aviation, its four-bladed Curtiss electric propeller gleaming under display lights. The paddle blade modification that transformed this aircraft from victim to predator represents one of engineering history's most decisive improvements, simple change that altered warfare's trajectory through systematic application of industrial technology. The Thunderbolt's legacy extended far beyond its wartime achievements. Post-war aircraft development incorporated lessons learned from the P-47's modification program. Incremental improvements could achieve performance gains equivalent to complete redesign while maintaining production efficiency and operational reliability. These principles influenced jet fighter development during the Cold War, when American aircraft consistently demonstrated performance superiority through systematic engineering. Advancement. Educational programs use the P-47's story to illustrate democratic societies' technological advantages. Students learn how free exchange of ideas, industrial competition, and engineering innovation combine to produce military capabilities that totalitarian systems could not match. The aircraft serves as tangible evidence that open societies possess inherent advantages in technological competition. Veterans. Organizations preserve memories of P-47 operations through reunions and historical presentations. Former pilots describe the confidence that came with flying aircraft capable of engaging any enemy fighter on equal or superior terms. Their testimonies emphasize how technological improvements translated directly into saved lives and mission success. Historical research continues revealing new aspects of the P-47's impact on aerial warfare. Recently declassified documents show that German aircraft development programs shifted toward defensive systems, specifically because of P-47 performance improvements. The Thunderbolt had forced enemy technological priorities away from offensive capability toward survival, a strategic victory achieved through engineering. Excellence International military aviation programs study the P-47 modification as an example of cost-effective performance improvement. The propeller upgrade success demonstrates that sophisticated engineering analysis can identify critical performance limitations and develop solutions without requiring massive resource investment or production. The pedal blade propeller itself has become an icon of American technological innovation. Engineering schools use its development as case study in problem identification, solution design, and implementation under wartime pressure. Students learn how systematic analysis and creative thinking combine to solve seemingly intractable performance problems. Today, the sound of restored P-47 engines echoes across airshow venues, reminding audiences of the aircraft that helped secure freedom through superior technology and industrial might. Each flight honors the memory of those who flew these modified Thunderbolts into combat, confident that American engineering had given them weapons worthy of their courage. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.